Hey, what's up guys? So let's take a look at this thing called RAG. What is it and why do we use it? So before we jump into what it is, let's take a look at why do we need it? What is it used for? When you chat to a chat model like ChatGPT, it's usually got a cutoff period in terms of its knowledge. So it knows everything, say, up to the end of 2023. So anything that happened in 2024, it doesn't have any context of. Let's say somebody invented a new way of how to make eggs. Now you go to ChatGPT and you want to find out, well, what is this new way? How do you actually use it? How do you make these eggs? Now you ask it the question and it's like, I have no idea. So the reason for that is because it's been trained up until a certain point in time. So you can obviously train it on new data, but the problem with that is that it's expensive and it takes some time. If you train it up until now, it'll know everything up until now, and a month later there'll be some new data. It wouldn't know what is going on when you ask it the question. So how do we actually solve this in a simple manner? So this is where RAG comes in. So RAG stands for Retrieval Augmented Generation. So let's take a look at a simple overview of how this works. So normally you'd have a user ask a question that goes to ChatGPT or whichever model you're using, and that generates a response and gives it to the user. So how does RAG fit into this whole picture? What happens is the user here asks a question like, hey, what's this new way of making eggs? Right? So now we have a database over here, and this is called a vector database. So what is a vector? A vector is just a numerical representation of text. So the reason we have it as a numerical representation of text is just to make it easier for the computer to do certain calculations on it. And we'll get deeper into that in a moment here. So basically we've asked it, what's this new way of making eggs, right? Now this gets given to a program that searches this vector database for any relevant data to what the user has asked. It retrieves it, and then it gives the original question that the user asked plus the retrieved information to the large language model, like ChatGPT. It then generates an answer and gives it back to the user. So that's how we get around this knowledge gap of the large language model. And by the way, a large language model is just a type of artificial intelligence that's trained to understand and generate human language. So let's jump a bit deeper into this concept of a vector database. Like, what are vectors and how do we actually store information in this thing so that we can get it back when it matters? So what would generally happen is you would have some kind of document, right? In this example, I'm just using a paragraph about Paris, France, and just a random sentence here. So keep in mind, a model like ChatGPT has a certain context that it can take in terms of input. Like if you try and cram an entire book in there, it's not going to be able to take the entire book because it's going to cut off at I can't recall what the exact cutoff is these days. I think it's 128,000 tokens or 200 tokens or something like that, which is still significant, but what you would generally want to do, especially if you have a long document, let's imagine that this is a very long document. You would split it up. In this case, I'm splitting it into sentences. You could split it into paragraphs, into chapters. So we're splitting this into sentences. So this is the first sentence, second and third sentence out of this paragraph. Now what we're doing is we're converting it to something called a vector embedding. And if you recall, like I mentioned earlier, all that is just a numerical representation of text. This is what it looks like. And this is just so that we can perform some calculations in the background to get the relevant data to give to the large language model. So once we've converted it to these vector embeddings, we store it in this vector database. And this is just going to contain all of our information. So in this case, it'll be this paragraph. In your case, it might be a whole document about your standard operating procedures for your business, or an entire book, or whatever it is that you want to store in here. So now let's take a look at a full deep dive of what this RAG thing looks like. So if we go here, this is the RAG system under the hood. So the user asks a question. What is the capital of France? So what we do is we take this question, we convert it to a vector embedding to do a semantic search. And all a semantic search is just a type of search that focuses on the meanings of words. So it won't take the user's question, what is the capital of France, and try and find these specific words in the data that it's searching through. It's going to take the actual meanings of words using some mathematics behind the scenes to try and get the most relevant data to this question. So we take this semantic search and we search the vector database and we get these chunks. As you can see, this one's about Paris, this one's about France. Technically, both of them are about France. But what you'll see, if I scroll back up here, what wasn't retrieved is this sentence right here, because this has nothing to do with France. So once we get that information back, we construct a prompt that we're going to give to our large language model. So the prompt would look something like this. Here's the user question, what is the capital of France? Here's the relevant information, and here we inject what we retrieved right here. And then we say, please answer the user's question based on the above information. So then the large language model would generate a response, and it would look something like, the capital of France is Paris. Then it shows that to the user. So that's essentially how RAG works. So this way you can get around the model's knowledge gaps. And it's quite easy to feed your own information into the model so that you can have, say, a chatbot on your website answering questions about your own business. So now that we know how this works in principle, let's take a look at a real-world example of what this looks like. All right, so we're now in Flowise, which is just a no-code, low-code chatbot builder. And I've put together a pretty simple RAG system here just to show you an example of what this would look like. So I'm just going to run through these components quickly so you know what's happening. So this is just a representation of what AI we're using, GPT-4o Mini. We have our text splitter. If you recall, what we had to do is we have a piece of text and we split it into chunks, right? So what this is doing is it's splitting the text into 1,000 characters. And we've got a 200 character overlap. So if we have a paragraph, we're going to take the first 1,000 characters, then the next chunk is going to take the next 1,000 characters from position 800. So it's going to have 200 characters of the previous paragraph at the beginning, basically. That's just to kind of keep overlapping context so that whatever chunks we retrieve, it's not like completely separate, so that the AI knows what's what. So in this case, I'm using a file loader to, I've got a copy of Moby Dick, the book. So this is what it looks like. Basically just the entire book. So what we're doing is we're splitting it into chunks of 1,000 characters, and we're storing it in Pinecone, which is acting as our vector database right here. And then we've got the OpenAI embeddings, which is just the service that helps us convert to the vector embeddings to create these numbers. And then we've got the buffer memory node right here, which is just storing the conversation history. So like if I ask a question, I get an answer, and I want to ask a question on that answer, I can basically ask that, and it will have context of what I've previously asked the chatbot. So let's take a look at what this might look like if we actually ask this chatbot some questions. So if we look at the book, right, there's this character, Queequeg, that keeps appearing throughout the book. So let's ask it the question, who is, however you pronounce that. Right, there we get an answer. And what you'll see is that there's specifically 4 document chunks that it's retrieved. So you'll see here some context about this guy. I'm assuming it's a guy. As you can see, this is what we retrieve from the vector database. So just to show you a little bit more about what happens here, I'm going to jump into Langsmith, which is just a way to see what's happening behind the scenes with these chatbots. And if we go down here, what you'll see is that we're giving the chatbot a system prompt, which is just overall context, like, hey, this is what we're doing, and like, this is what I want you to do. So we're saying, I want you to act as a document that I'm having a conversation with, and so forth. And then we're giving it the context. And these are the chunks from the book. So these are the 4 chunks that we've retrieved. And that's pretty much it. And then we give it the question, who is this person? And it gives us an answer. And this is what's displayed to the user. So that's basically it in a nutshell. Oh, and just to show you a little bit more about this concept of a vector. So if I jump into Pinecone, if we look at this is essentially the text that we're creating a vector embedding of. And this is what the vector looks like. If I copy this and I put it into a text editor, this is essentially the numerical representation of this text. It's quite something. But in any case, the computers behind the scenes know what to do with these numbers. So I want to show you one more real-world example of how you might use this kind of system. So what I have here is just a mock document of standard procedures for a sales position. So things like what to say if the customer says, like if the customer gives a specific objection. So what you might do is obviously have your salespeople aware that this tool exists. And then if they get an objection, for example, if the customer says, I'm not the decision maker, as an example. So let me clear this up. By the way, I've uploaded a different document here, the sales guide. So let's say, what do I do if the customer says, I'm not the decision maker? So there it says, if the customer says I'm not the decision maker, you should 1, 2, 3, 4. And what you'll see is that this should match exactly to this right here. So this can obviously be expanded on greatly. Like you can have not just one document, you can have a whole like directory of documents. Like if you have a ton of standard operating procedures and as a business owner, you're getting nagged the whole time by your employees. What do I do if this happens? What do I do if that happens? You just either create the documents if they don't exist, or you take existing documents, you load them into a system like this, and you give your employees access to it. Then they can ask whatever questions they need to ask. So that's pretty much it. I hope that was a comprehensive overview of what RAG is. And yeah, if you enjoyed the video, give it a like, and I'll see you in the next one.